Okay, so today we're going to talk about features 2, alright, which is just a continuation of modeling in SolidWorks. We're going to learn how to create these fillets here, okay, the chamfers, but more importantly the whole wizard. Okay, a whole wizard is a tool you use very frequently. It lets you build all kinds of counterbores and tapped holes and things like that. And one of the main benefits of it is that if you use it right, you can extract the whole nomenclature on your drawing, which can save you a lot of time. So you will see the benefit of this tool as we progress through this tutorial. So as you can see, there's no start file. There's no start file. Everything's gonna be built from scratch, but we do have the solution. So what I'm gonna do is just start creating a new file. Alright, in SolidWorks, and we're just going to create a new model just from scratch. Okay, here's a new model. I'm just going to set this up. Remember, anytime you create a new model, you have to change the options, tool options, change the standard to ANSI and change the units to IPS. Okay, we're going to do that for every model. Also, it's good to save your model. Okay, just going to save it as exercise number 8, and now we're ready to go. Okay, so if we look at the first step, we're not given a lot of direction as far as how to build this. So really, relying on you to review what we learned on the last tutorial to build this. So there's a lot of ways you can go about this. You can build this with 2 extrusions, one extrusion for that, another extrusion for that. You can build this with one oversized extrusion and then an extrude cut, just like they would in machining. In machining, you start with an oversized block and you mill it down. Or you can build this from the side. You build this, you draw the sketch, extrude that back, and then use the revolve tool for that and extrude that towards the back. So as you can see, there's a lot of different ways you can approach this. So that's the first step. There's really not anything new here. It's a repetition of the last demo. So again, I'm just going to build this using the center rectangle tool, and on the top plane, just because I feel like it's a flat piece that you would look at it from the top down. And I'm going to snap to the origin. Okay, again, that's very important. I'm going to snap to the origin because again, this piece is relatively symmetrical. Alright, and I want this to snap to the center. I want these to be centered about the model because again, it's really good practice. This is why I'm using a center rectangle tool and snapping to the origin. And if I look at the isometric, I'll notice that this is 4 and then this is 5. And as you can see, this is fully defined, which is very good for me. For instance, if I deleted this, you see this is not defined. This is not good. It doesn't know how long it is. The model's got to know how big everything is. So this is good. This looks pretty good. I'm going to exit out, and I'm going to extrude this 1 inch. 0.75 plus 0.25. Okay. So I'm going to simulate the way this is made in real life. Just because sometimes I've had machinists call me and say, I need to see how you build it because it's going to help me figure out how I'm going to program it on the CNC machine. So I always like to build the model like it would be made in real life. So that's 0.75, 0.25. Alright. So now I'm going to build this feature. I'm going to build that feature, and I'm going to do that. I'm hitting Control 8 to stay normal too. I'm going to do that by sketching inside this feature. Okay, I need to draw the box of this. I could do it with a corner rectangle tool. I mean, I could just do this. But to show you another way, convert entities also is good for this. The way it works is you select the edges, okay, and you hit convert entities, and it converts the edge into a sketch. So I'm going to just use that just to show you something different. Alright, then I'm going to continue on and draw lines and circles to match the sketch that we saw. Here may be a new tool for you. It's called the Trim Entities tool. And when you click this Trim Entities tool, there's a power trim, meaning you just click, you hold the left mouse button, you just drag and drop. and it trims anything in its way. So I kind of like that tool because I remember in ancient AutoCAD programs you had to pick, what do you extend, what do you trim, it's a couple clicks, but with a power trim you just drag and drop, and it's pretty cool. Alright, so that looks pretty good. I like it, but again, it's not defined, and the reason for that is because I didn't put a 1.25 dimension. So I'm going to go ahead and put a 1.25 dimension on that line. And as you can see, it's fully defined now. Okay, so there's many different ways you can approach that using the tools that you see here. I'm going to exit out of the sketch. I'm going to hit Features and hit Extrude Cut, and I'm going to set this to 0.25. I selected, it knew what I wanted to select just by because there's only like one sketch to select, but if it didn't know, I would have selected it here from the tree. Okay, this is 0.25, cuts in just like that, and looks good. Okay, moving on to step 3. We're going to learn about the fillet tool. Alright, so here's the fillet tool. You can also find it here. And there's many different fillets that are out there. Variable fillets, full rounds, all of that. Fillets are really just to make the part more ergonomic, meaning it's easier to use, it doesn't hurt the operator. But you usually just spec that on an injection molded part so that it can easily eject from the mold, and also because it makes sense for injection molding. But for machining, it doesn't really make a lot of sense. Usually you put a chamfer if you really need to break a sharp corner. Fillets are mainly for the injection molding industry. They're not really for machining. So let's talk about how you implement them. First, you put a dimension here for the size, and then you pick the edge that you want it on. You can also select it asymmetrical. So if you want some sort of elliptical fillet, you can do that too. But we're just going to stick to symmetrical for today. So we're going to stick to 0.5, and we're going to select each of these edges, and we're going to also select this edge on the top. Do you notice how it transitioned that edge all the way around? It's because I have a tangent propagation on. If I turn it off, you'll notice that the fillet is only on one edge. So as you can see, it can be on either or. Alright, so this is a very useful tool. In some cases you'll need that, in other cases you'll need that. Okay, so just be aware of that. It's also a good idea to put a fillet on top of another fillet. What I mean by that is it's good to do fillets in multiple steps, because sometimes you can't just get the effect that you want in one step. So when that happens, I just select the fillet tool again and I add another fillet. Like for instance, if I tried to do that in one step, with this, it'd give me a lot of problems. So it's very common to put fillets on top of other fillets. In this case, I'm going to do a very special fillet. I'm going to select this whole surface. I'm going to change this number, and as you can see, it figures out that I need a fillet on all those edges. So I could have done that with just selecting each edge like this, right? I could have done that. But just wanted to let you know, you can select not only an edge, but also a surface, and it will figure out all of the edges around that when you include the fillet. Okay? So that's what that looks like. And as you can see, you can go back in time anywhere you want, okay, to see every step. Another thing I wanted to talk about real quick is when you create a sketch, I mentioned that you can type in a number, but you can also type in an equation. I'm not sure if I went over that. So for instance, you can type in 2/3 and it figures out that value as an equation. You don't have to put 0.67 directly. And also you can put an equation. So if I start with an equal sign, just like Excel, to start an equation you gotta hit the equal sign. If I do Excel, if I put an equal sign, you can put an equation. So just like Excel, you set a reference, then let's say we want to do times 3. Alright, so now this says that this diameter is 3 times the size of that one. When you do that, you get a sigma. It means there's an equation tied to that value. So now when I change this to 1, you see this automatically updates by 3. So a lot of suppliers, a lot of companies that use SolidWorks, they like to use the equations because it's easier. It updates. It makes the workflow a lot easier because everything updates in one shot when you use an equation. Okay, so I'm just going to undo that. Okay, because otherwise I'll get a bunch of errors. And Sometimes I've noticed that when you get an error, it's best to just delete and start over, or just hit undo, as opposed to try to troubleshoot it. Sometimes that tends to save you some time and tends to be an easier solution. Okay, moving on to the next tool, which is the Hole Wizard tool. So again, there are two main benefits to using this. One is that it extracts all of the hole nomenclature on your drawing, and also that it uses industrial numbers that are uniform across the industry, which will save you a lot of time. So I'll show you how these two things are going to be beneficial for you later in the tutorial. So when you follow this guideline, this step, all you got to do is just follow the steps. There's step 1, step 2, step 3, step 4. So that's how you use the Hole Wizard tool. So we're going to go ahead and use the Hole Wizard here. Now traditionally when you set the position of the hole, what you do is you click, well you first create some sort of array box like this, set it for construction, and then you kind of snap to each location just like that. Okay, that's kind of the traditional way, and then you start dimensioning this grid. Okay, that's kind of like the traditional way of doing this. But I made it a little bit easier for you on this tutorial. The way we're gonna do this is really just by snapping to the origin, just because you're getting started, and that should be good enough. So anyways, it's located there, and then if you follow the balloons, it said, all right, step 2, select the type, which is a countersink. Then you select the angle, which is 100 degrees. They only sell these in 2 different angles, so it's going to be 100 degrees. This one's going to be 5/8 for diameter, and it's going to be normal fit, meaning this inner dimensions are going to be normal. So if you pick close or normal or loose, you can see how this is getting larger and larger. If you need to deviate from the numbers of the 5/8, you can hit custom sizing, and you can change these numbers to anything that you want. And it's going to be a through all hole, just like you see here. Click OK, and there it is. There's the result. Okay, so now if you want to modify this at any time, it's very easy. Just edit feature. You can modify the sketch anytime, you can modify any of these features anytime, and you're good to go. Okay, so let's practice this a little bit more. Let's use the Hole Wizard tool to create a counter bore on the corner here. So I'm going to go to positions, going to hit Control-8 to stay normal to. Actually, it's not what I wanted, so I'm going to hit the arrow keys to kind of increment my angle. And I'm going to pick this surface. I'm going to snap to I'm going to make a hole that's concentric about this fillet. So I'm going to hover my mouse over the edge here and then just snap to that center. Then what I'm going to do is I'm going to use a counter bore for this, just like the tutorial. Okay, we're now on this step here, step 4.3. Okay, so this is a counter bore. It's not for a socket head cap screw. Okay, it's for a socket head shoulder screw. Socket head cap screw is probably the most standard hole type that you use in machine design. The socket head cap screw, 1/4 bolt, that's like where you start. But the shoulder screw is what we're going to use today. Okay, so shoulder screw, socket head cap screw, 1/2 inch. Fit is normal. 1/2 inch is actually the diameter of the shoulder. It's not the head, it's the shoulder diameter. And everything else is going to be okay, just like that. So there's the shoulder screw. Now let me show you why this is so useful. Okay, why this Hole Wizard is so useful. So let me save this. And well, the first reason is, let's say I were to create a drawing. We're going to learn about drawings in a future lecture. But let's say I created a drawing. And I inserted this model that I just built. Alright. Okay. See this? See, with just a click of a button, I get all that nomenclature, right? So remember, a few weeks ago we learned about what this means. We learned about this, and we learned about these symbols. And it was tedious. It was tedious to draw that by hand, and it was prone for error. But with the Hole Wizard tool, as you can see, everything is generated in one shot. This would not happen if you used the Extrude Cut tool twice. If you used the Extrude Cut tool twice, you would not get all this nomenclature. And the nice thing is that you can modify this at any time too. I mean, if you want to turn this into a 1/4 inch hole, you can do that. And watch what happens when you go back to the model. See, it turned this number. It updated all these numbers. Okay, so that's the first benefit of the whole wizard tool. The second benefit is that these numbers are standard. Okay, so let me show you what I mean. Let's go back to the 1/2 inch. Alright, these numbers are standard. So let's say, for example, I'm going to save this. Let's say I went on a supplier site. Okay, make master car. And let's say I wanted a shoulder screw, right? Shoulder screw. We said diameter 1/2 inch. Okay, and let's pick this one. Alright, let's say we want this bolt. So let's say we create an assembly. We will learn about assemblies later. And we import our model, and we import a bolt. So here's the deal. This is a 1/2 inch shoulder screw that I spec'd. This is a 1/2 inch shoulder screw I imported from a supplier site. And watch what happens when I put the two together. Okay. As you can see, they both fit perfectly. Look at that fit. See, that's the advantage of the whole wizard tool. I don't have to look at some catalog. I don't have to look at some industrial standard and see, all right, what's the size? What's the diameter of a shoulder screw? What's the depth of the head? I don't have to do that. If I use the whole wizard tool and I just spec, hey, I want a 1/2 inch shoulder socket head cap screw. Look at that. Look at that clearance. It figures out. It fetches all the values from the industry so that I get a perfectly clean feature. All right. So this is really good for us. So again, if you need to create a counterbore or a tapped hole or anything like that, don't just use the extrude tool, the extrude cut tool. Use the whole wizard tool. Okay, so now let's go back to our model. The next step is to add a relief. We're going to cut this off here. As you can see, I'm going to shave it off. Sometimes engineers remove, when a counterbore is close to the edge of a model, they like to shave off the side because it's a thin feature. A thin feature is not desirable in design because it wears out quickly. It's not a strong design. So anytime you see a thin feature, you want to eliminate that. You want a robust, strong design. So when the counterbore is towards the edge, usually you shave that off. If it's in the center, it's alright, but if it's towards the edge, you want to shave it off. So we're going to do that using the extrude cut tool. Okay, so what I'm going to do is just draw. I mean, there's so many ways you can approach this. I'm creating a sketch on this surface, if you noticed. And I'm going to just draw a circle here. And I'm going to snap. I'm just drawing a box. Alright, I'm drawing a box. And I'm just adding some relations. You see, I'm just making these connect. Okay. Hope you understand what I'm doing here. I'm just drawing. I'm drawing a shape that I'm going to use to shave off the edge. I don't know why this just jumped. That's alright. I'm just going to add another relation. Okay, there's many different ways you can approach that. Using the relations that you learn, using the sketch tools that you learn, I'm sure you can figure out a way to create the sketch. But what you gotta understand is the process. I'm selecting the surface, I'm creating a sketch on it, and now I'm going to exit out of that and use the extrude cut tool and go all the way through all. The other way. See this arrow? Click the arrow. It's gonna cut through all. And see what you get here? You get a very nice, clean relief. So this is a lot better than leaving that thin feature there. Okay, don't be lazy about small stuff like that. You know, you want to have a clean geometry. All right, so that's how you create the relief. Okay, now what I'm gonna do is, since the same piece is everywhere, I'm going to mirror it. I'm not gonna just build this 4 times, the relief, the whole, you don't want to do that. It's just a waste of time. So what I'm gonna do is I'm just going to mirror this twice. Okay, so you hit mirror, and you gotta pick the features. So I'm gonna pick this feature and the hole. All right, so if you're not sure what you're selecting, again, it's the counter bore. That's clear. Counter bore and the relief. I could have renamed this relief to make it easier, but that's what I'm essentially doing. Mirror about the right plane. So let's see what we get when we click this. Okay, you see that? This mirrored over to the other side. And now what I'm going to do is mirror my mirror. You see, mirror on the front plane, mirror my mirror. So now what you get is the same feature on the other side. So the reason I like working like this is because, say I want to change this. I don't want to change this 5 times. Alright, all I gotta do is just go back to here, or better yet, I go back to here. Say I want to change this to 1/4 of an inch. Look at that, all 4 update at the same time. And then all 4 update at the same time on my drawing too, right? So that's cool, because again, remember back then in the 90s when they built CAD programs, you had to draw each of these lines by hand. This was drawn by hand, this was drawn by hand, this had drawn by hand. There was no intelligence between the pieces, but with the new modeling techniques, now everything communicates. So with just a click of a button, my drawing updates, my assembly updates, my part updates, so all of that gets done in one shot. Okay, so that's how you use the mirror tool. Okay, so let's see what else. Good. Okay. The chamfer tool is similar to the fillet tool. Okay, it's just kind of like a straight edge. Something like that. Sometimes to deburr, if you remember, the burrs are kind of like these residual pieces of metal that stick out after you cut metal. It's good to chamfer that so that the burr is removed. So sometimes the chamfer tool can be good for that, but a lot of times I don't see. It's kind of understood to deburr your parts, so I tend not to model the chamfer, because sometimes I've had machinists call me and they say, "Hey, what's the actual dimension that you want this chamfer to be?" And personally, I didn't really care about the angle. I just wanted it to be deburred. But I just want to show you an example of how the chamfer tool might be used, is to deburr a certain edge. An alternative to the hole wizard is the simple hole tool. As you can see here. See the simple hole? It doesn't let you do as much as the hole wizard tool. It doesn't let you do threads or anything like that. But it takes less resources. It's lighter weight than the hole wizard tool. So sometimes you can use that. Also, one thing to note with the hole wizard tool is when you create a tapped hole, let's say we want to create a tapped hole on here. You can, again, like I said, you can bypass any of these numbers. If you want something more specialized than what the default is, you can change that. You can set the blind depth for the hole. You can set the blind depth for the threads, okay, and the threads are always going to be less than the center drill depth, okay, but you can spec all of those things. Okay, you can change all of those values. And also, look at that, you can change the class too. Remember, one is tight, one's loose. You can change all those things, and what's cool is that all that is going to display. Like if we go back to our drawing, all that is going to display here by, look at that, it tells me the class. So you can modify all those things, all the things we learned about thread specification. You can modify those things on the model here, and all of that can be changed. Okay. So you even have NPTs for fluid distribution. All right. You have countersinks, counterbores, clearance holes, tapped holes. Okay, so you have pretty much all of the major types of holes that are used in mechanical engineering. And if you messed up, you typed in something you didn't mean to type, you can hit restore default values, and it will reset the standard industrial numbers for that hole specification. So let me delete that. Okay, so that's that. And then remember, when you're done with a model, always remember to add properties. And we talked about that. This is so that when you create a drawing, those properties are going to extract. So you can hit material, you can hit print number, you can hit, whatever you want. Okay, just follow the tutorial. Add the properties as shown in the previous demo, and then you can type whatever you like here based on what the model has. And then finally, I always like to laser mark the model. Okay, so you're welcome to do that. Okay, maybe this is some sort of cast product and you want to laser mark. So again, you can do that with the text tool. Just like that, and wrap it. The extrude cut tool also works just as fine, just as good. On here, 0.1, and change the color to that surface. Okay. Maybe you want to show that this is a cast product. And you want to show these are machined. And you can even change the texture of that so you get like this brushed machined look. Okay, you can change that through the textures and the bump mapping. I mean, there's all kinds of textures like for cast products or machine products. You can modify all of those things, even here. All right, you can change all of those properties. You can make it even more shiny if you want. Here's the reflection amount. So okay, so again, this concludes this tutorial. Again, the main focus here is understanding the whole wizard tool, how to apply it, and how it's beneficial as far as the drawing is concerned, as far as mitigating errors when you design.